Okay, so let's get started on part 2 of section 1.3, coming to you Mapton, Washington. Oh, there you are. Late. Alright, so now we're going to start talking about special patterns. And the first of these is the difference of two squares. So let me talk about that briefly. Here's an example right here. X squared minus 4. The key to realize on this is that, first of all, we don't have a trinomial. So here's the basic idea. When you have a difference of two squares, let's say we have like x squared, and let's think of it as having a middle term equal to 0. If you have a 0x, and then you have like minus 36. Well, if we're factoring this, like we were doing the previous ones, what we'd need is two factors of 36 that give me 0. Okay, and it has to be negative. So I think you realize one of the factors would have to be 6, and the other factor would have to be negative 6. Does that make sense? One wouldn't have to be 6, one have to. And that's the only way we're going to get 0 in the middle. And that's kind of how these things work. So we end up with x minus 6 and x plus 6. And so, now normally when we're factoring a difference of two squares, we don't write this in here, and we leave that part out. And you see this. Alright, let's pause.
Good morning.
Thank you. So we have a difference of two squares here. So take a look here. If I rewrite this, we have x squared minus 6 squared. You see, there's the perfect square right there. So those of you that aren't familiar with the perfect squares, I have a poster on the left side here. You should probably be aware of the first 12 from memory. The first 12 square numbers and the first 12 square roots. Like square root of 121, it's 11. And so on and so forth. So those you should kind of know and commit those to memory. Anyhow, breakfast is over. Can't be eating, okay? So here's the thing though. As you can see here, the difference of two squares, we get x plus 6 and x minus 6. Now, if you use the same idea, and there's a plus sign here, you see, let's look at this instead now. Let's just change this real quick. Let's put the 0x in the middle again. And now let's put a plus 36. Now remember, we don't really need to write this here because there's a 0 right here. But it might help you understand how this works if you put in a 0 just momentarily. What two factors can we use of 36 now that give us 0? You can't. Well, you could either, you see, you need two numbers that multiply that give you 36. There's a positive 36. You see, there's only two ways to do this. You could either have negative 6 times negative 6. That would give you a positive 36. But if you were to add these, you'd get negative 12, right? The only other way to get 36 is using 6 itself and 6 itself over here. And if you were to add those, you get positive 12. So notice that you cannot get 0 if this is a positive. And that's why up on the board you see a squared plus b squared. We say that this is prime. Okay? So the sum of two squares does not factor. It's only the difference of two squares. It's when you have the difference, when you have subtraction going on, that you can factor it. Because in that case, you'll have one positive, one negative. And that's how you get the 0x in the middle. Okay? So if you kind of have that understanding, it'll help you understand how the difference of two squares works. So maybe we can do a couple examples here. Maybe try this one real quick. Y squared minus 121. Okay, hopefully you recognize the pattern. It only takes you 10 seconds to factor this. I'll let you try it first on your paper. Recognize that as a perfect square. So hopefully what you recognize is that that is the same thing as 11 squared. So now you have a difference of two squares. There's a square, there's a square, there's the difference. And so this factors to y minus 11 and y plus 11. You see? So the special pattern that we have a squared plus b, excuse me, not plus, minus b squared. It's equal to a plus b and a minus b. Now notice what's over here is not the a squared and b squared. It's a and b. So often when I'm helping people, I try to tell them, let's try another one. Let's say we have like 16 y squared minus 25 x squared. When we're factoring this, you have to identify what the a and b's are. So here's a little intermediate step I recommend doing. I recommend rewriting this as 4y, the quantity, squared, minus 5x, the quantity, squared. And now you can identify quickly what the a and b are. Your a is the number here, and your b is the number here. And so now to factor this one, you'd say 4y minus 5x. And then the other factor would be 4y plus 5x. Does that sort of make sense? Yeah. So when you're factoring this, you want to be able to identify what the a and b are, and that's what some people make mistakes with. Let's try maybe one more to make sure you have this.
So if b was 0 squared?
If b were 0,
Yeah.
well then you wouldn't have a difference of two squares. You'd have a squared sitting there. Did I answer your question?
It's on that study guide that you use.
Oh, it is?
Yeah, it's on
Which?
the-
What does it say?
It says 25a squared minus
25a squared minus what?
k squared.
Minus k squared. Okay, so in this case, b is not equal to 0, it's equal to k. So here's what I would do. Again, I would recommend that you rewrite this here. Write it as something squared. In this case, what would this be if it equals that? It would be 5a, right? And I would rewrite this one as something squared. In this case, what would the something be? K, right? By doing that, you now know what the a and the b are in this case. Okay, so now you'd write this as 5a plus k, and the second factor would be 5a minus k. Now once again, why is there a plus and a minus in here? That's part of it, because there's a 0 in the middle. Does that make sense? The only way to get 0 in the middle, there would be like a 0 AK in the middle, right? Because there's nothing sitting here, right? In the middle. So you have to get 0 there. Now let's multiply this out real quick just to see that. So 5 times 5 would give you the 25a squared. But when you multiply this one, what do we get? We get negative 5ak. And when you multiply the inside, you get a positive 5ak. And when you multiply the last times the last, you get minus k squared. You see, these are the two that are opposite in sign, so they give you the 0 that we're after. And see, so that's why you don't see it up here. Okay? So this part would disappear, and you end up with what we started with right here. So hopefully conceptually you can understand how this works, how one of these factors has to be positive and one of them has to be negative. Otherwise you won't get 0. Okay, so I think you have that one figured out, and that's the difference of two squares. I have it written up on the board. And remember, from memory you should realize that the sum of two squares is prime. Okay, so let's talk about another one that's a perfect square. This time we have a perfect square on the right side, and it's going to be handy to recognize this pattern. And you might see in the beginning that you could have just factored this and you would have gotten the same answer. And at first you might say, well, why do I need to check this pattern? Well, let me just tell you, in the future you're going to be doing something very similar, but we're going to be factoring cubes instead of squares, and they use patterns also. And so you want to get handy at checking the patterns, because that will help you factor the cubic ones when we get to them. So just keep that in mind. So let's take a look and see what this is about. What we're looking for when we multiply a square, let's just see what happens. If you have like x plus y and we square that, let's just look at the pattern that happens. This is equal to x plus y times x plus y. And when you do first times first, you get an x squared. And when you do this one times this one, you get an xy. And when you do this one, you get another xy. And when you do this one times this one, you get a y squared. Now notice what always happens whenever you square something, you get the same thing in the middle. That's why we have an x squared plus 2xy. And then we have the y squared. So, whoa, what happened? Wow. I don't know what happened there. Sometimes the mouse button gets stuck, I think. Let's back that up. Back that up. Yeah. Put a square. Okay, so this is the pattern you want to check. So if you see this pattern, then you immediately go to that. Does that make sense? So let me show you what we're talking about now. Let's continue.
You would just write the x plus y parentheses and squared
Yeah.
as the final answer.
Yeah.
Oh.
Yeah, let me show you how it works in practice. So let's say we have x squared plus 10x plus 25. Now, what I'm trying to do is I'm going to check to see if this pattern holds. Do I have an a squared? Do I have a b squared? And do I have a 2ab in the middle? This is what I'm looking for, that pattern. Well, you see, take a look. This a matches up with that number. That's a perfect square. Check out this number. This number, I'm thinking to myself, is 5 squared. So it's a perfect square also. There's the b right there. You see? Now the question is this one that? Okay, so before I do that, let me show you an intermediate step that I always do. That's how I do this, okay? If this is my a squared, what's a going to be? No, a would be x. A would be x, right? If a squared is this one, then a is equal to x. If b squared is 25, then what's b? 5. Okay? Now what I do to check the middle is I simply multiply these two together and then double it. So 2 times x times 5. You see? Does that give you the middle term? It does. That's 10x, isn't it?
Yeah.
So that what that means is that this is the pattern right there. That's the pattern. What it means is that this factors to a perfect square. And you put the perfect square up there, and your a and b go in right here. This is x plus 5. This whole quantity squared. So what you're doing is you're checking this trinomial, and if it has a special pattern, now it won't always have this special pattern. If it doesn't have this pattern, then you might have to factor it the old-fashioned way that we learned earlier in the section. But if it does have this pattern, then you can factor it fast. Well, let's try a couple other examples. I think this next slide has some examples. Okay. So this first one you should recognize is a difference of two squares. Anyone see okay? Let me switch colors to white. Mentally in your head, you should see this as x, the quantity, squared, minus 7, the quantity, squared. And now you can see it's a difference of two squares. Okay? So this factors to the special pattern x minus 7 and x plus 7. Okay? So that's a special pattern. Now my friends, all these special patterns, you should memorize the patterns and how they work. There's only 3 of them, so you're going to have to memorize 3 of them. Now, let's check here. Now, the way that you suspect this is you look for perfect squares. I notice there's a perfect square here, and I know this is a perfect square because that's 6 squared. Okay? Does that make sense? And so now you might suspect, oh, hey, this might be one of those special pattern problems. Yeah. Scoot it up. I'll try to. Is that better?
Yep.
All right. So you might decide, hey, I want to check that pattern. Well, the pattern, again, has to be like a squared plus or minus. It could be minus here, too. 2ab plus b squared. Okay? So you're thinking, oh, well, maybe I should check this pattern. Well, so once again, if that's the case, let's just check it out real quick. If this is a D here right now, let me switch colors. This is a D squared. So if that's my A, if that's my A squared, then what's A equal to? D. Okay. And if this is my B squared, then what's B equal to?
6.
Hopefully you say 6, right? Because that's 6 squared. Well, now let's just multiply the two together and then double it. So that's 2 times D times 6, right? You doubled it. That gives you the 12, right? What you just checked was this pattern, and that's the pattern you see right here. And so this factors to the special perfect square. Now, here's where people mess up. What goes in here? What goes in here? It's A and B. So it's D plus 6. Now, how do you know if this is a plus or a minus in there? I mean, it could be plus or minus sometimes. If there's a negative right here. You see, sometimes there might be a negative sitting there. Like, look at this problem right there. There's a negative there instead. In that case, you check the pattern again, but you're going to write like D minus 6 instead or something like that. Let's try this one real quick. Now, why do we suspect that this might be a pattern in the first place? Well, first of all, you see a perfect square there, right? Is that a perfect square?
Yeah.
Now, what number squared is that?
13.
It's 13 squared. So you should, anytime you see a couple of perfect squares sitting up here, you might suspect, oh, this might be one of those special patterns. In this case, because this one's negative, what we're looking for is a squared minus 2ab plus b squared. And if we have this pattern, then it's going to go to a minus b, and it's going to be a perfect square. Okay? So let's check and see if we have the pattern. Well, if this is my a squared, then what's a? And you say z. Hopefully everyone besides Noel is saying that. Alright, now if this is my b squared, then what's b? Hopefully what you're saying is 13, right? Now if we take these two and double it, you've got to multiply those two together, you'd have 2 times z times 13. Okay? And that, I believe, is 26z, right? And so you say, hey, I have this pattern right here. That's the pattern. So this is simply equal to what? Something squared. This is why you went through the trouble to find A and B, because now it's Z, and this time it's minus 13. You guys catch why it's minus?
Yeah.
Octavio, why is it minus?
What?
Why is this a minus in here? I flipped a coin, and half the time it's positive, and half the time it's negative. No, it's negative because of that one. Yeah. If the middle term's negative, that's going to be negative. On the previous one, we saw that the middle term was positive. Let me just erase that so you can see. The middle term was positive. So that's how you determine the positive, whether it's positive or negative in here. Okay, so checking this pattern is worthwhile. Now, let me just show you one real quick. You might say, I could have done it faster without doing that. Like, for example, let me just give you another one. Let's say we had x squared, and let's say we had plus 6x here, and then we had plus 9. Now let's say you didn't know that this is a perfect square, and let's say you just said, oh well, let's see, I need two factors of 9 that give me 6, and you'd say, well, 9 times 1 and 3 times 3. Well, which factors work to give you the 6? You'd say the 3 and the 3, right? So then you'd say, oh well, this is x plus 3 times x plus 3. And then you'd say, hey, wait a second, that's the same thing as x plus 3, the quantity squared, because there's two of them. And you might say, well, that was just as fast. Why do I care about checking that pattern? I mean, I've been telling you you should check that pattern. Well, again, the idea behind checking this pattern, the a squared plus or minus 2ab plus b squared, you want to be pretty good at checking this pattern, because like I said, later on in the future we're going to be doing cubics, and they do patterns also. So if you get in the habit of checking patterns now, when we take the next step on checking patterns, you'll be used to how this all works. Does that sort of make sense? So I know it might be a little bit more time consuming right now, but you want to do it. Just be in the habit of doing it. Okay, so let's go back and let's look at those special cases one more time real quick. There's the 3 special cases. That's the difference of two squares, and then we have the perfect squares. Now notice the only difference between these two perfect squares is that middle term. The middle term is positive here, it's negative here. If that middle term is negative, then you get a negative here. If the middle term is positive, you get a positive here. But you have a squared and you have a plus b squared here. It's very similar. The only difference is that sign right there. So those I have written on the board, and the sooner you could memorize these 3 patterns, the better. That's just my recommendation after teaching this many years. People tend to do better if they have these memorized. Okay? And you could rely on the board and look up there every single time if you want. But like I said, if you just have these 3 memorized, it's probably faster for you. And you'll probably do better on the test. Okay, so let's continue. I think we're getting closer to finishing. In fact, why don't we stop part 2 right now? Well, let's just do these 3-4 problems together real quick, and then we'll stop part 2. And we'll finish part 3 tomorrow. Part 3 will only take about 10-15 minutes, and then we can have the remainder of the period to work on this assignment. Okay? I told you these sections take a while. They take about 2 or 3 days each. So, anyhow, hopefully this only takes 10 seconds. Honestly, you should be able to do that in 10 seconds. You should recognize the pattern. There is no middle term, right? So basically it's got to add to 0, right? So you have to use x plus 3 and x minus 3. Okay? How about this one? Go ahead, Joel. Q.
It's q plus 10
Q plus 10 and Q minus 10. Okay, right on, I agree. Now, what about this one? This one, we suspect that we might have that pattern to check. Why? Because there's a perfect square here and that's a perfect square. You guys should recognize this. Recognize that's 8 squared, isn't it? You see? There's a perfect square. And so you might be suspicious and you might decide, hey, I'm going to go ahead and check that pattern. Mr. Russell told me it's going to be a squared plus 2ab plus b squared. Well, I already know I have 2 perfect squares here. So let me just work out the pattern here. If this is my a squared right here, then what's a equal to? And you say y. And if this is b squared, then what's b? You say 8. And if we multiply these two together and we double that, we have 2y times 8. We do get 16, which is in the middle. And that means you do have this pattern here. And so you can go immediately to the step where it's a perfect square. And what goes in here? Y plus 8. There you go. You found it. You found it already. And it's the y plus 8. So y plus 8 goes in here. And can we do this last one? We only got about 3 minutes. We're on our short period today. So once again, you see perfect squares, right? There's a perfect square. This is a perfect square. Hopefully you recognize that that's 9 squared, right? So you suspect that you might have this pattern. The only difference on this problem is that there's a minus there instead, right? So let's check real quick. Do we have the pattern? Well, if that's my a squared, then what's a equal? W. And what's b equal? 9. And now if you multiply these two together, you get 9w. You need to double that though. And so that does equal 18. And so that is our special pattern. So we get this times this squared. We get w minus 9. Any questions? Okay, so this is where I want to stop for part 2. Now, you might want to do some more of your study guide and try to get that done. I think for the most part you can finish the study guide or get close to finishing it.